In this video, I'm going to solve a couple of quadratic problems and also show you how you can expand and simplify some slightly more difficult problems. The first we have is x brackets 3x plus 1 equals 0. And we're just trying to solve this problem. Now, this looks like it hasn't been factorized completely because it's not in its normal form, but actually it has. You're more used to seeing it look like this. Which we would clearly see my two solutions would be x1 equals 0 and x2 equals negative 1/3. Now this is exactly the same as the problem over here on the left, because to make this part equal to 0, my second solution of course will just be minus 1/3. To make this part here, while it's not in a bracket, it's still something that we need to make equal to 0. We can actually just say x equals 0, and it makes the entire thing equal to 0 because 0 times whatever's in the brackets is still going to be 0. So it's actually slightly easier to solve than normal problems. And the same rule applies if we have something like 2x brackets 3x minus 1 equals 0. My two solutions will be x1 equals 0 and x2 equals positive 1/3 for the exact same reason. Plugging in 0 makes this part 0, therefore the entire thing is 0 because they're being multiplied together. The second example I'm looking at is expanding and then factorising this expression here. Now there are a couple of ways you can do this type of problem. You can expand it as it asks you to do, which we'll try first, but there's actually a more clever way of factorising this problem. So let's start by expanding. Best to do the thing that is in brackets first. So I'll leave the 9 out here and then write this as x minus 2 because this part here is actually a perfect square because it is a quadratic into a single bracket that has been squared, minus 16. And then we will expand the two sets of brackets to get 9 like that. You can then keep expanding. And then you might simplify. And now you want to factorize it. So we can't see any common factors here. So what we'll try and do is our cross-multiply factorizing method. So I'll do that over here. I'll list my factors. I might try, say, 3 and 3 and 5 and 4. We can see multiplying here gives me 15, and that gives me 12. It's not what I'm after, so let's keep trying. If I reversed 5 and 4, that wouldn't help. So I could try maybe 10 and 2. That will give me 30 and 6. So that will work. These will both need to be negative, so therefore these two are negative. And so I get 3x minus 10 and 3x minus 2. Now that's one way we can solve it. The other way is a bit trickier, but it's a lot faster. We can actually think of this as a difference of two squares. This here is a square. This here is also a square, and they're being subtracted. So the square root of this is actually just 3x minus 2. If I multiply that by itself, I get 9 brackets x minus 2 squared. And then the square of this one is minus 4. And the other one will be 3x minus 2 again, but then I'm going to add 4. And as you'll see, that is exactly the same as this expression over here when you expand this part and simplify.